All right, so we are going to start with logarithms, which are related to exponentials. And I'm going to start you off with a short, like 3-minute video that kind of explains them. And then I'll repeat some of what the video said here.
How does the difference between 0.00000000398 and 0.00000000398 cause one to have red eyes after swimming? To answer this, we first need a way of dealing with rather small numbers, or in some cases extremely large numbers. This leads us to the concept of logarithms. Well, what are logarithms? Let's take the base number b and raise it to a power p, like 2 to the third power, and have it equal a number n. We get an exponential equation, b raised to the p power equals n. In our example, that'd be 2 raised to the third power equals 8. The exponent p is said to be the logarithm of the number n. Most of the time, this will be written log base b of the number equals p to the power. This is starting to sound a bit confusing with all the variables. So let's show this with an example. What is the value of log base 10 of 10,000? The same question could be asked using exponents. 10 raised to what power is 10,000? Well, 10 to the fourth is 10,000. So log base 10 of 10,000 must equal 4. This example can also be completed very simply on a scientific calculator. Log base 10 is used so frequently in the sciences that it has the honor of having its own button on most calculators. If the calculator will figure out logs for me, why study them? Just a quick reminder, the log button only computes logarithms of base 10. What if you want to go into computer science and need to understand base 2? So what is log base 2 of 64? In other words, 2 raised to what power is 64? Well, use your fingers. 2, 4, 8, 16, 32, 64. So log base 2 of 64 must equal 6. So what does this have to do with my eyes turning red in some swimming pools and not others? Well, it leads us into an interesting use of logarithms in chemistry, finding the pH of water samples. pH tells us how acidic or basic a sample is and can be calculated with the formula pH equals negative log base 10 of the hydrogen ion concentration, or H+. We can find the pH of water samples with hydrogen ion concentration of 0.00000000398 and 0.00000000398 quickly on a calculator. Punch negative log of each of those numbers, and you'll see the pHs are 7.4 and 8.4. Since the tears in our eyes have a pH of about 7.4, the H+ concentration of 0.70398 will feel nice on your eyes, but the pH of 8.4 will make you feel itchy and red. It's easy to remember logarithms. Log base b of some number n equals p by repeating the base raised to what power equals the number. The base raised to what power equals the number. The base raised to what power equals the number. So now we know logarithms are very powerful when dealing with extremely small or large numbers. Logarithms can even be used instead of eye drops after swimming.
Okay, so his voice was a little annoying, but so that's kind of a basic idea of how logs work. So I know sometimes you might be thinking, okay, well, I'm just off by like 1 decimal point, but that made a huge difference there, right? And so your accuracy in things definitely is important here. So let's look at how this works. Now some of these variables in here are different than what was in that video, but it's the exact same thing. So we're going to take the log form and change it to an exponential form because that's what, we kind of understand a little bit better. But the way you would read this, so it says this is log base b, so it's like a little subscript there, of a equals x. So when you go to write it in exponential form, whatever the base of the logarithm is, which is b, is the base of the exponential. So that base to this power, you go around in a little circle, b to the x power, keep going around, equals a. That's how you rewrite it back and forth, okay? So we have a common logarithm. They said this one's used so often it has its own button. Most calculators now will actually do logs of other bases, but it takes more button pushing. Usually just the log base 10, it's a pretty accessible button if you have if it has it on there. So it says a logarithm with base 10 is called a common logarithm and can be written without the base. It says can, but it should be, and it almost always is. So here, if you look at, just look at this one, you have log base 7 of 49. So here, log base 10 of x is really just log of x. You leave the 10 off. It's kind of like having a 1 in front of a variable. You just know that it's there. Okay, so you would know that that's log base 10. Okay, we okay with that? Questions we got? All right, so let's convert. We're going to convert back and forth between the two forms. So this one says write it in exponential form. So we're not solving for anything. We're just rewriting things. This is log base 7 of 49 equals 2. So the base of the log is 7. It becomes the base of the exponential. That's the power. 7 to the second power, come all the way around, equals 49. And that makes sense, right? 7 squared is 49. So. All right, on number 2, what's the base of that log? 10, because it's not there, so I know it's a 10. And that goes to the third power equals 1,000. Okay. You do the next two. Okay. Do you agree with what I wrote? Okay, so let's have a little quick review on these exponents real quick. If I have fractional exponents, that 9 to the 3 halves power, that's 3 halves is the same as 3 times 1/2, right? What do you do, what does it mean when you take something to the 1/2 power? Remember that? If I have x to the 1/2 power, what's another way to write that? Square root of x, right? Remember that with your fractional exponents? So that 9 to the 3 halves power, that's the same thing as taking the square root of 9 and cubing it. Square root of 9 is 3, 3 cubed is 27. Okay, that's the way those work. Your negative exponents mean it's going to change it from numerator to denominator or vice versa. So if this is just 4, this is the same. So 4 to the negative 3 power is the same as 1 over 4 to the third power. And then that's where you get that 64 from. Okay, so just little reminders on some exponent things. All right, let's rewrite the exponentials into log form. So the base of the the base of the exponential, which the base would be 3, becomes the base of the log. So this would be log base 3, and then you go around in a circle again, of 1 over 81 equals negative 4. Okay, so it's just a statement, like that's what's true right there. Number 6, well, we know anything to the 0 power is 1, right? But this is, the base is 8, so this would be log base 8, go around here, of 1 equals 0. So the log of any base of 1 is always 0, because when you rewrite it, that's basically what's going to have to happen there. Okay, we good? All right. Number 7, the base is 10, so do I write the base? No, this would just be log of what? Got to go around the equals. Log of 1/10 equals negative 1. Make sure you go around in a circle around the equal sign. You do number 8. Okay, so log base 12 of 2 squared of 3 equals 1/2. Do we agree with that? We're all good? All right. So that's just rewriting. We're not solving. We're doing just rewriting it. You got to know how to rewrite it so we can get a little farther than this. Now this actually says evaluate, which means I need an answer. So it helps if I'm evaluating or finding something if I have a little equation. So I'm going to set this equal to x so that I can rewrite it exponentially, because exponentials are going to make way more sense to you than logs. So if I was to rewrite this, this would become 6 to the x power equals 36. Okay. And then I just want to get common bases. So 6 to the x power equals 6. Well, 6 to what power gives me 36? 2. So if 6 to the x equals 6 squared, then x has to equal what? 2. See how that works? All right, so then I'm going to set this equal to x. Then I can write 2 to the x power equals 128. So I'm going to have 2 to the x equals 2 to something, okay? And when you figure this out, I count on my fingers as well. I'm going to go 2, 4, 8, 16, 32, 64, 128, right? So that was 7, so it would be 2 to the 7th power. So then x equals 7. You okay with that? All right, let's set this one equal to x. So I've got 3 to the x power equals 1 over 27. So I'll have 3 to the x equals 3 to the something. Before you worry about what the number is that goes up there, what does it have to be? Negative. Good. It must be negative. And then 3 times 3 is 9 times 3 is 27. So it'd be to the negative third. So x equals negative 3. Everybody okay with that? All right. Set this equal to x. That will give me 9 to the x power equals 1. I need a common base, but I can't be 1 because 1 to any power is just 1. So this would be 9 to the x equals 9 to what power is going to give me 1? 0. So then x equals. Okay. What questions you got? All right. Now I want you to do number 15. So the base is 10, right? So when you get your common bases there, we know it's going to have to be negative because it was went to the denominator, and it'll be negative 2. So x equals negative 2. You agree with that? What questions you got? All right. So rewrite this one as an exponential. I got 16 to the x power equals 2. You agree with that? So our common base, I think we would agree here, would be 2 and not 16, right? And so if this is going to be 2 to something equals 2 to the first, I have an x on here, but I need a number in front of that x. It's like 2 to what power gives me 16? So that'd be 2, 4, 8, 16. So this would become 2 to the 4x power. See how I had to put the number on that one instead of the other one? And that's just a 1. So now that I have my common bases, 4x equals 1. So x equals what? 1/4. Okay, we're good? What questions you got? All right, let's set this one equal to x. So I'm going to get 16 to the x power equals 1 over 32. I can't use 16 or 1 over 32 as a common base. The square root of 16 is 4, but I can't use 4 for 32, so I'm going to have to go all the way down to 2. So see if you can rewrite this. 2 to something times x equals 2 to some power to where it would be the same. See if you can come up with what those would be. So the question you need to ask yourself here is 2 to what power is 16? So it'd be 2, 4, 8, 16. So that's 4, so that'd be a 4x. This was 1 over 32, so you know it's going to have to be negative. If I had 4 to get to 16, and then 16 times 2 is 32, so that would be the negative 5 power. Make sense? Then you got the common bases, so now we know that 4x has to equal negative 5, so x equals negative 5 fourths. What questions you got? All right, you try number 18 from scratch. Two to the 2x equals 2 to the what? 7. So then 2x equals 7, x equals 7 over 2. Yes? What questions you got? Anything? Got to be able to multiply. All right, so let's say that we rewrote that and then we couldn't get a common base. Like what if this was 129 instead of 128? Then I couldn't get a common base, so I couldn't figure it out that way. Instead, I may have to use the change of base formula. So it says some logarithms are not as easy to evaluate as those above and will require the change of base formula. One of the reasons you would use the change of base formula is to be able to type things in on a calculator where you couldn't do other bases, which like I said, most calculators you can now, but there are other reasons you may need to simplify or whatever. But if I have log base b of a, right, I can make this into common log. We're going to use base 10 because that's just going to be the easiest way to find it on a calculator. You're going to make a fraction, and you're going to have 2 logs, one on the numerator, one in the denominator. This is different than something else we'll get to where we combine them into 1 log. This is going to be 2 different log base 10. So I'll have log over log. Log base 10 over log base 10. The base of the log goes on the bottom, so this would be the log of b, and then log of a in the numerator. So base is bottom, that's how you remember how to do it. It's that easy. Okay, so log base 20 of 4, another way to write that is to have a fraction. We're going to have a log, right? It's base 20, so 20 goes in the denominator, 4 goes in the numerator. And then you would type it in on the calculator. We're not going to use the calculator today because we don't need it for most of what we're doing. I'm just kind of explaining to you what to do with that. All right? So then this one on the numerator would be log of what? 2. And the denominator would be log of 6, right? The base goes on the bottom. All right. We don't need to do 23 and 24 because it's that easy. All right. So we talked about E when we did exponentials, right? We've got E with the logs as well. So we have a common log that's base 10, and then we have a natural logarithm that has base E. So a logarithm with base E is called a natural logarithm. This, you don't ever write it like this, okay? That's just kind of explaining to you what it is. Log base E of x is the natural log. That's a lowercase l and a lowercase n. It's not an I, okay? Natural log of x. That tells you that the base is E. So when we want to rewrite these in exponential form, it doesn't look like there's a base there, but because it's a natural log, the base is E. So the base right there that you don't see is E. So I'd have E and I do it the same way, to the fourth power equals x, right around in a circle, right around the equal sign. So you do number 26. '26 would be e to what power? X equals 10. Good. Make sure you go around that equal sign, because it's easy to do, but it's also easy to mess up. So then going the other way, this is, does that say e to the x? It just looks like a blob up here to me. If I want to rewrite this as a log, the base of the exponential is e, so the base of the log is e, which means it's the natural log of 50 around equals x. So then you do 28. This would be the natural log of what? X equals 0.5. What questions you got? All right, awesome.